What is going on, everybody, and welcome to part 2 of the Reinforcement Learning with Stable Baselines 3 tutorial series. In this video, we're going to be talking about saving, loading, and tracking the performance of your models. So this is the code that we left off on. We definitely learned that something is happening when we train it for X number of steps. The problem is, how many steps do we train for? And as we saw for sure with A2C, I didn't even look through the PPO, but we definitely saw where performance at one point was actually in the positives, but it ended at 100,000 steps with a reward in the negatives. So how do we deal with this? So that's what we're going to be focusing on here. So first off, we will go ahead and we will import OS, and then we're going to specify a models directory, and this will just be, we'll make models slash, and in this case, depending on which one we're using, so in this case we're using PPO, so for now I'll just say PPO, but if we change the algorithm, change that name. Don't be like me and forget. I'm sure I will. So that's models dir, and then we'll also have a log dir for, whoops, I didn't mean to run that. I have to, what have I done? Log dir equals logs. So once we've specified those, we want to make sure they exist. So if not os.path.exists and models dir, we want to os.makeDirs models dir. And then we're going to do the exact same thing for the log directory. So paste, cool. So that'll make them if they don't already exist. These lines are totally fine. And now what I'd like to do is set time steps. So this could be in the form of 1,000 time steps or 10,000. It really is going to depend on how quickly does your environment step, in my opinion. So this just comes down to essentially how frequently do you actually want to save your model. So for now, I'm going to also comment this out because this was to actually run it, and we'll get to that on the load here in a little bit. But for now, what we want to address is training and saving. So in this case, let's say we're going to train every 10,000 steps. You can change this to be 5,000, 10,000, 2,000, 500, whatever the heck you want to use. Put that number in. I'll go with 10,000 since that's relatively quickly. So let's say what we really want to do, and we'll actually make a constant here. Time steps, we'll say 10,000. So model learn for those time steps. And then we'll say for I in range, and then how many time steps do you want to do? So in reality, we might actually make this a while true loop, but just so it'll be easy for me to kind of compare the two, again, we'll be comparing A2C and PPO here. So I'll just limit it in some way. But for I in range 30, what we're going to do is model.learn for that many time steps. Now, if we just leave it this way, the model will reset every time the number of time steps that it's already taken, the model object, I mean. So every time you do model.learn, it would reset the time steps that it's at. But to stop that, we can say reset num time steps, and we'll set that to be false. And then we'll also set a tb log name. And again, we'll set that to be PPO. I feel like we need to have a constant, probably. I think we'll be okay with 2 places to edit, but if we add any more, I think I should, we should probably have a variable for that. But anyways, whatever. Model.learn, so this reset time steps will help both with the output that we see in the console, but also in the tensor board itself. So model.learn, and then basically all we're going to add is model.save, and we'll use an F string here, models underscore, oops. We wanted to use those variables. Models dir slash, and then in this case, it will be, we're just going to save time steps times I. So we'll say, whoops, not a capital I. Dude. There we go. So go ahead and save that. So now, essentially, this will be time step 0 the first time through, and in fact, maybe we'll do a range 1 to 30 to make this actually accurate. Otherwise, we'll be 10,000 steps off. So model.save. So now it will save that model every 10,000 steps. So I'll go ahead, save that. And in fact, I think we probably want to run this in its own little console. So we'll go ahead and run this. Python 3, P2, save.py. Let's make this a wee bit larger. And let's go ahead and run that. Make sure we don't hit any errors. So far, so good. Okay, and that's off. That is training our model for PPO. Now, what I'm going to go ahead and do is let's just shift. I'll put this over here, I guess. So I'll move that over. I wish it told you somewhere in that output what type of model it was, but that's okay. So we got PPO training. Now I'm going to go ahead and toss in A2C to kill two birds, one stone at a time here. So let's make sure that we make all the changes that we're supposed to make. Ooh, a find and replace probably would have made sense, but that's okay. A2C, wasn't there one more spot? Yes, there was. Not that. It'd be an interesting model. Okay, so I think we're all set. We'll go ahead and save that. Let's confirm that we got models or logs. So this will be TensorBoard here. Models, PPO. So yeah, we have our 10,000, 20,000, and 30,000 steps models already in there. Whoops. And I think we're good. So let's just double check, make sure I didn't screw anything up. In fact, let's go PPO. Found that one. It's a good thing we didn't do a find and replace, isn't it? Anyways, okay, cool. So now, whoops. Now we'll save. And let's go ahead and I will run that one as well. So open in terminal, Python 3, P2, save.py. So again, this should be running for A2C in our case. So again, we'll make it a little bigger. And I will wait for that to at least start to output something for us. Let me check A2C, cool. And let's go ahead and check logs. Logs is empty. Why would logs be empty? Is it possible? Why would logs be empty? Maybe it's every 100,000 steps. Is that what it's going to do to me? I would think it would update the logs every 10,000 steps. Oh, I know what I've done. Okay, so I forgot to, in model, I told you we weren't going to be adding anything else, but we are. So in here, we're going to say TensorBoard underscore log equals logdir. And then this is the TB log name. Dang it. Okay, so, okay, I'm going to break these two that are training right now. And come back over here. I just want to clean everything up. So actually, I'm just going to delete that. Okay, coming back here, A2C, cool. I wish I would have checked that earlier. Anyways, let's rerun that. So this will be A2C going, and we'll make sure that we're actually logging this time. Okay, that's training. We'll come over, well, let's confirm before we waste our time, shall we? So A2C underscore 0, cool. Models, A2C, very well. Okay, so now what I want to do is switch this to PPO. Copy, paste, paste, paste. And just to be sure, A2C, very good, we don't have A2C. And we'll rerun PPO now. I'll slap this over here. Also, a little curious, NVIDIA SMI, curious where I'm at GPU-wise. Okay, my GPU, yeah, we're comfy. Thanks, Puget. So, okay, so now we have our things training. We should have TensorBoard logging happening. So now to actually view the TensorBoard, what we'll do is, actually we need to be in that directory. So we'll come down here, open a terminal, and we'll go TensorBoard logdir equals logs. Very well. So, okay, so here, although the graphs are very, very small, admittedly, let's make this a little bigger. So the main graph that you're probably going to care about the most is the reward average. Okay, and in this case, PPO is our blue and A2C is our orange. So you probably care about the average reward the most. That is typically the thing that we're trying to create here. But the length of the episode also can carry quite a bit of significance, and maybe more on that later. We'll see. So PPO blue, A2C is orange. Okay, so what I'm going to do, I think, is I think I can do this. No, that's the wrong button. I never remember which ones are the right buttons. So I'm going to let these things train for the 300,000 steps. Hopefully I got that right. It should take somewhere before that. We should be able to solve these models. These are very simple models. Okay, obviously this is still training, and we'll continue to let it go for the 300,000 steps, but eventually we'll get to 300,000, and either way, while you're training, like I said, typically you're going to probably be using a while true loop rather than any known ending. So now what we would want to do is, looking at our reward mean, we might say, okay, we want to take PPO at, maybe, I don't know which one will we do, 180 or maybe even 175, but we wouldn't have that saved. So it'd either be 170,000 or 180,000, either one. We can just grab one of those. Let's say we want to load that and run that. Also, interestingly enough, I'm kind of surprised that we actually see A2C overtaking PPO. This is not... That's not nothing is what I've expected so far in this series. Like, I expected our random agent in part 1 to be way more wild, but actually our random agent in part 1 was, I think, better than the 100,000 agent. It's just like, what the heck, man? I'm trying to make a tutorial here. Let's go look at some of these metrics, though. So one thing that should be pretty clear by looking at these, they are different algorithms, so take this with a grain of salt. But in general, the reality, or the thing that I was hoping to be able to show even with the reward here is, but you can also see it with the reward. PPO is a smoother algorithm. In general, it doesn't have as much volatility. And one thing you will grow to really hate as you train these reinforcement learning algorithms is how volatile they can become, right? Especially like when I was doing DDPG, for example, with the robot dog. It was very frustrating to have a model learn, and then it just tanks. It just explodes, and it's like no good anymore. It's like, it really guts you. So, in general, I like something that is a little smoother, and we can see that basically in all of these other metrics, like entropy loss, basically all of these metrics across the board. PPO is the smoother metric, and so for that reason, it is a little less stressful to use something like PPO. Also, in general, the performance is much better. In this case, it is comical to see A2C is it still winning? It is still winning. In reward. Okay. Live demos. So the other thing to think about, too, is a lot of models can be dictated by just randomness. So where did you randomly initialize and where did you start taking steps from there? So you can do two things. You can either set your random seed specifically, or I kind of just like to just run a few models randomly, like to test a model, test your environment. I would run like 3 to 5, something like that. I've seen huge variation in exactly the same code, and in fact, maybe what I'll do before we leave, it'll probably be an exact match, but before the end of this tutorial, I'll run one more PPO, and in fact, we can just run it. I think we can get away PPO. Maybe make the models dir could be a -2. And I don't want to overload the GPU, so I'll wait until one of them is done. But I'll show you at least another tensor board before this is over. And you can hopefully see some of the variance. My guess, anyways. This environment is so basic that maybe there won't be much. But anyways, let's get to loading and kind of seeing one of our examples in action. So for example, let's say we want to take PPO, and I forget already what was a good PPO one. Which one is PPO? It's our blue. So let's take PPO at 180,000. So while things are training, we probably want to see where we're at along the way, because again, you'll probably wind up doing it for just a while true loop, and you might want to actually visually see it. So sometimes you'll see the reward is what you want, or maybe the episode length is what you want, but nothing beats visually seeing it. So again, for example, with the robot dog, sometimes the reward looks really good, but then you load it up, and either one, the actual agent is somehow defying the laws of physics, like it has found an actual like bug in the environment, which is pretty common, or two, maybe it's doing something really dumb that will never be recovered from. So one example that I've seen again from the robot dog scenario is it would like jump and do like this kind of roll, but get stuck on its back. And it was probably never going to get out of that. That was a really short-term kind of gain in reward, but then actually recovering from that, I've never seen it happen. It's possible that it could like jump and roll and then jump and roll and then jump and roll or something like that. But in general, it's good to see it visually so you have an idea of like what's actually going on in your environment to cause that reward. Even though it might look good on paper, in practice it might not look good at all. So we want to see what's going on. So to do that, we still need our environment. We do need a model, but we're going to use our one of our saved models. So I'm going to copy the models dir, paste it over here. And the first thing that we want to do is we're going to specify our model path, and that will be the we'll make that an F string, and it will be models dir, and then slash whatever that file name is. In this case, we'll do 170,000.zip. That one was looking good, at least to start. And now what we want to do is actually load that model. So we're going to say model equals, and this will be ppo.load, and we will load in the model path, and then we specify the environment, so it'll just be env equals env. Now we want to actually run with the model. So episodes 10, that's totally fine. We get the observation. Yeah. Cool. Basically what we want to do is swap out this action here. So we're going to cut this out, and we're going to say we want to take an action. Now what is that action going to be? So to make that action, we're going to say action equals model.predict. And actually it's going to be action, and then we'll just say like underscore. In this case, it also, the model.predict is returning some states. So if you are using, I'm not touching this right now, but if you're using a recurrent algorithm, this will be of use to you. But for now, we're not doing that. So we really only care about what is the action. So we're going to say models.predict, or model.predict rather, and that observation. So then we'll do the step based on our actual model's action. We will get all of this other information, and then basically continue the loop. So let's go ahead and save that, and we can run that. Maybe. Yes, okay. So here we have, I guess because I've changed the name, it's all itty bitty. Let me fix that. Beautiful. So here we can see our actual model in action. This is our PPO model. So the episode length is starting to make a little bit of sense now. It's not terrible, right? It's not crashing, but the goal is to land in between these two flags, and it's definitely not doing that right now. But this is better than random, and it's better than the 10,000 model. But clearly we need to possibly continue training. So let's go ahead and check. Let's see here if anybody got even better. No, our best model in this case was actually around maybe 190, but also interestingly, PPO and A2C performed identically. This is so frustrating. Yeah, you do, like, definitely PPO is supposed to win here. I can't believe this. And PPO also just turned to crud by the end. This is hilarious. So what I think I'm going to do now is I'm going to train like, I guess we'll do another run for each of them, to be fair. So I'll run another PPO and another A2C, but also while we're at it, let's go ahead and check an A2C at, I guess, 190K. So we'll come over here. We will, oh, it already died. It died before I could do it. So we'll change this to 190, and then we'll change this to A2C. We'll change this to A2C. Cool. And let's just go ahead and import PPO and A2C. We don't need to be switching that around every single time. Cool. Run that. Wait for it. So here's our A2C. It looks pretty good too. It's very comparable to our. I don't think we ever saw PPO actually succeed in any way. This is interesting. When I was like making the text-based version of this tutorial, this is like nothing like I was seeing. It's funny. Classic. So, okay. So now what I want to do is I'm going to train both of these again, and maybe I'm going to walk away while I train these. So I'll do like 1,000,000 steps just because I am surprised at our results thus far. So cool. So what I'm going to do is we'll just kill this. And P2 save. Let's do models do PPO. So the only thing, if I want to run a bunch of PPOs, would be here. And maybe what I'll do is import time. Let's get real fancy about this. Super fancy. We'll do an int time.time. Cool. And 30. Let's do I really want to do 1,000,000 times? Kind of. I kind of want to see a better result here. What was it? So 10,000. So we'll do 100 time steps. And I think maybe I'll do like 2 and 2. So let's save that. P2 save. So what I'll do is come over here. I'll run P2 save once. Okay, it was trying to rewrite to the other TensorBoard logs. So I guess we'll also say logs, and then we'll do this: logs / PPO time.time. What did I screw up? Boom. Okay, try that again. What I really want to see, like I was trying to overwrite each other. So here, I'll show you what tipped me off to that one. Okay, well, maybe it was this one. I might have made the logs a little messy, but yeah, I saw logging to logs, and then it was just PPO_0 for both of them. Obviously, we don't want that, because then we'd have crazy logs. So hopefully we didn't totally murder. Well, we did. We murdered our other log, but that's okay. That's all right. Okay, that one is running, so I will run one more PPO. And just to clean up the logs, I will come into here, and I will delete. Maybe we'll leave the original A2C, but this one's been ruined, so I'll just delete it. And now what I'll do is I'll also add an A2C. Take that. Pasta. A2C. A2C. I bet we could have fixed it with that. That would have been the more proper place to fix it, actually. Now that I think about it, we should have added the time to that. I don't think it will be relevant because it just doesn't really matter, but we should have added the timestamp right there. Whatever. I think we're fine. So let me check for PPO again. Cool. Okay, so now what I will do, we'll just run 2 more of these. Python 3, P2 save. And I'm just going to open a tab. Python 3, P2 save. Let's check models, make sure we're not screwing ourselves there. Look very good. And then we'll check logs. That's looking good so far. And then finally, let's check TensorBoard. Looking good, looking good. I wish I didn't delete the original PPO. Oof. Whatever. Okay, so see if I can fit this on the screen while it trains. Very good, very good. Okay, about an hour and some change, hour and 20, 30 minutes or so has gone by. We are finally done training everything here. And interesting charts for sure. So checking out kind of the results, it does look like our best performer is this PPO model here. But also curiously, I believe that's this guy right here. Yeah. So also curiously, where's the top? There it is. Who's our second best here? See, like our second best was like sort of even this like A2C for a second. That for the original one that I said was really good for an A2C model, by the way. That was actually our second best for a little bit, and then it appears that it kind of went bad. Oh well, that was the one that we trained for only 300k steps. But then it's another A2C model that was actually pretty good for a little bit, and then yes, it throws it all away, just like the other one was clearly going to do, and it never recovered. But by the end, the two victors here are PPO and PPO. So if you can use PPO, use PPO. It seems to be the best one that I've, at least in my experience of using. And in all fairness, A2C, I don't know anybody that's still using A2C for anything specific, but anyways. So we have our results. We've compared models. You've seen now real examples of how that random initialization can make all the difference. So again, you might want to actually explicitly set your random seed possibly, or just simply train a handful of models. In my opinion, I would just kind of randomly train a few models, and then whichever one is going well, continue training that model. I don't really see any statistical reason why you want to set like random seed 0, for example, for all the algorithms that you test, because in theory you might be, maybe you were that bad PPO from before, when really you could have been good PPO if you would have allowed that seed to come across your desk. So anyways, let's check out one of these PPOs. So it looks like maybe around here is one of the better ones. So where are we? Step. So let's do the 550K PPO. So let's check that one out. So P2 say P2 load. I already know. I got to figure out what was the 550,000 and which, before I forget. So let's see. Let me change this to be PPO. And which one was that? PPO. Is there a way I can just... Yes. I'll do that. Maybe? Cool. Come over here. Paste. I think we can get away with that with the models dir. We'll save that. Let's run that and see if that works. Beautiful. Look at it. Look at it go. Yeah, so yeah, that's probably solved. We'll look at a few more, but I would say at this point, yes, that is indeed solved. So the other thing that I wouldn't mind checking real quickly while that continues to play is what was our best A2C. It looks like A2C, like our original A2C is the best one that went for 300,000 steps. So the A2C at about not quite 200K steps, but maybe 190. Yeah. So A2C 0 at 190K looked pretty good. So let me, I guess I'll move this over here. You can watch that. And we'll just check it out. So A2C 0. Is that going to be right for the models, Let me check that. That'd be right for the logs, but for models, yeah, it's just A2C. I already forgot what I said. Was it 190K? Okay, so this is our A2C. Yeah, I mean, it's not quite as good as the PPO. It did learn, at least. But at least for sure on this environment, I see no reason to use it. PPO is faster, and PPO is better. So hopefully now you've got an even better understanding of reinforcement learning, stable baselines 3, and you're coming to grips with how to change your algorithms and all that. Now, up to this point, we've been using these pre-made environments, and like I've been saying, the really true hard thing is to figure out which environment do you want to use PPO on. So I'm just kidding. There are other algorithms, and obviously PPO is no good for. There is continuous PPO, but again, we'll talk more. I promise. After the custom environments, we will talk more about continuous versus discrete and all that kind of stuff. But I think the next best thing to do is, I think anybody who's getting into reinforcement learning, if you're not just doing it just for the kicks, is you want to apply this to your own environment. So in the coming videos, what I'm going to do is we'll just take some environment I can find online. I'm thinking some sort of Pygame game or something like that. Convert that to a gym environment. So show you kind of the steps that are involved to do that, and then actually train a model in that environment. Again, because this is an environment that we're going to have to make up the observations. So you'll see that it's not, in this case, we've just been handed observations. So how do you come up with your own quality observations? How do you start thinking in that way? And then also how to come up with your rewards. Because again, these two things are actually deceptively complicated sometimes. So I think you'll see a few good examples as we go through that. So anyways, that's all for now. Thanks for watching, and I will see you guys in another video.